Okay, I think everyone answered all the questions. So let's see number 11. Which of the following all occurs when an Amazon Elastic Block Store backed Amazon EC2 instance in Amazon VPC with an associated EIP stopped and started? So all data on instance store device will be lost, and the underlying host for the instance is changed. So
sir, I can't see
elastic
your.
IP address, you know,
Sorry,
this is the
sir, I can't see
flexibility.
your
You
screen.
can actually detach or
Sir?
attach to any instance, and then you can attach to any other devices. So this is the flexibility they have. So underlying host for the instance is changed. That's the one thing, and also it's saying the if you remember, we have a two kind of storage. One is called
Hello?
the EBS, and the other
I
was
think you can
called
hear us.
instance store. The instance store was a temporary. Doesn't matter if you are EIP, EIP attached to that, or it has just a generic IP address. Every time you close it, it's going to lost the data. Okay, it's okay now? Okay, great. Sorry, I was on the other side of the screen. I have two monitors. I was watching other one with your test score. So let's get started with the number 11. In the number 11, I was talking about remember at the beginning of this course, we learned about the two kind of storage. One is the EBS, Elastic Block Storage, and other one instance store devices. So instance store devices is if you have any kind of IP address attached to that instance, when you stop and restart, the data will be lost. And if you change the stop and start, and it's going to change the host name. I mean, host name can be changed. The host you can actually detach the IP address from one instance, and you can attach to another one. So you can change actually the host if you are detaching and attaching to other devices or instances. So number 12, how many VPC peering connection are required for 4 VPC located within the same AWS region to be able to send traffic to each other of the, this is about the VPC peering. So you have, how many they have required? 4. So each is a 1-to-1 connection. So for each region, if there are 4, they need 6 connections to talk to each other, all of them, because it's a 1-to-1. You cannot have a transit connection. Which of the following AWS resources would you use in order for EC2 VPC instance to resolve DNS? So DHCP is a dynamic host configuration protocol that we learn in the VPC class. So it's dynamically going to assign the IP address to the instance or a host, and that will be resolved through the DNS which is Route 53. Which of the following is the Amazon side of an Amazon VPN connection? The VPG, Virtual Private Gateway, is the answer. What is the default limit for number of Amazon VPC that customer may have in a region? So default, you can have 5 VPC per customer in each region. That's the answer. You are responsible for your company AWS resources, and you notice a significant amount of traffic from an IP address in a foreign country in which your company does not have customer. Further investigation of the traffic indicate the sources of the traffic is scanning for open port on your EC2 VPC. Which one of the following resources can deny the traffic from reaching the instance? So remember, the security group provide the firewall at the instance level. From the network level, you always can deny to specific region, to a specific range of IP addresses, or you can deny to a traffic which is coming from a different country. So these kind of flexibility of denying and accepting is only available on the network access control list. In the security group, you just have 2 options. You can allow and deny, and that is going to be applicable to all the traffic. But here you can specify, you can specify if you want to deny request from my laptop, from my IP address, that is possible. Which of the following is the security protocol supported by Amazon VPC? So it's IP security, IPsec, that's the one. It's supported by the VPC. So which of the following Amazon VPC resources would you use in order for EC2 VPC instance to send traffic directly to Amazon S3? So remember, we did the exercise on the creating the VPC endpoint. Without sending the traffic through the internet, you can create a VPC endpoint. So that's going to be private communication between S3 bucket and your network. So for that, you have to create the endpoint. What properties of Amazon VPC must be specified at the time of creation? So you have to provide the CIDR block for the VPC and for the region where you are creating. So remember, we usually use 0.0.0./16. So that's a CIDR block representing the range of the VPC or the size of the VPC. So which Amazon VPC feature allow you to create dual homed instance? So it's like a elastic network interface, ENI. So when you have an ENI, you can assign more than one elastic network interface card to a host. So you can use one for the public access, and the other network card you can use for administration purposes. You can do SSH using one network card, and you can use the other network card for the public traffic. So we did, I think, very detailed lecture on that. So that is pretty good. Let's see what happened here. So 44 no answer. That's because we skipped the first 10 questions, and then we have 39 correct, 17 incorrect. Not bad. By the way, there is a service called recognition I mentioned yesterday, and this is we're going to use in today's demo. Last night I was just testing this, and I found very interesting things in it. If you upload any picture, this is called recognition, Amazon recognition. It will give you the detail what's in this image. So I uploaded Fahad's picture last night, and the first thing it told me that he's a human. And the second thing he told me he's a man. He didn't say he's a boy. Fahad?
मैं सुन के हंस रहा हूँ.
Let me see if I find the picture here. So I'm going to upload. So these are the fully managed services. When you say fully managed, you can just go there and start using it. This is one of the example. So I'm going to upload Fahad picture and see what's the result. Fahad is not giving me any result. I think I have to refresh it.
Watch it give you the other result.
Let's see. So where's Fahad? See, he says this is a face, it's a person, it's a human. And you have a tie, you have a head, and you have what? He's saying it's kind of portrait. And you are a man, not a boy. So we will be actually using this in our architecture today. Let me try one more person here.
I don't have dimples.
अंकल आपकी आवाज नहीं आ रही.
Okay, so before I get started with the DevOps, the first thing we need to look into what was happening in the software development environment. I showed you there was 3 level of environment. One is called development, second is called testing, and pre-production, and the last is production environment. But that was the environment where we actually develop the software and then test the software and then we run that in the production environment. But the methodology they are using to develop the application or any software, they used to call this the Waterfall Methodology. So SDLC stands for Software Development Life Cycle. So here, the first thing when the developer wants to develop an application, he goes to the customer and he collects the requirements. So he documents each and everything, what he's trying to do, what kind of business is, and what he going to get the value from the application which he want to develop to automate his business. After getting the requirement, the next stage is design. So these are the different phases of this methodology. So see, because the reason they call it the waterfall, because it's coming, once the one process is completed, then the next process started, and then so on, the waterfall like this. So design is completed, they reviewed the design, and then they did all kind of coding for that application. For example, they wrote like 10,000 lines of code, and now they are here for the implementation. And after the implementation, they are going to test the system. And after the testing is done, the system is ready to go into operation. So once this methodology was in place, there was a lot of challenges. For example, you design something and then you go to the customer and this customer don't like your design. And you have already written like 5,000 lines of code, and the outcome of that is not acceptable. It's not being accepted by the client. So think about that. You have to go back to the drawing board. You have to redesign it, each and everything, and then you come back and they present the new design. So it was a very tedious and time-consuming way of doing the software development. And sometimes you have to pause all these stages and you go to the production. And the production, which is the operational part of the environment, and in production side, the people who are actually going to use this application, they have a lot of challenges. They say this application is not working, it is giving different error, there's a lot of latency, the functions are not working. So there's a lot of things were happening, and the blame game was always there when this kind of methodology was in place. So operational team was always saying that the developer has not developed the right application. The development is not done properly. They have missed a lot of things. So somehow then they come up with a new version of application. They start all over again and they create a new functionality, and then they try to integrate with that. So this was, for example, this application going to start with the time period of timeline of like 6 months, but most of the project take like more than a year or maybe extra time to finally get accepted by the client. So these were the challenges in place when they were using the waterfall methodology. The next thing they came up, the solution for this was called Agile Methodology. In the Agile Methodology, I think this is in Agile Methodology, they came up with the idea, rather than doing all this development in a one shot, let's break down in chunks, like in small pieces. For example, we are going to create the login page. So once the login page is ready, give it to the test team going to test this, and after the testing is done, it's going to analyze by the customer, and if the customer approve it, then it's going to go to deploy, then it's going to the production. So this was the solution for the waterfall methodology. So this made this process fast comparatively the waterfall. So this was acceptable. The company started to adopt this agile methodology. So in this they have different stages. They design in a small pieces. There's one part of the application, maybe very small, and the most of the task duration time it was like 1 week or maybe 24 hours. So in 24 hours or 1 week, they have to deliver something. So what they do, they create a backlog. They create the list of the tasks need to be done in order to complete this application. So they start by starting with they then prioritize which task will be the first and second and third and fourth. So after prioritizing the task, they start developing the application and go to the design actually define that. Define mean they're going to write the code for that. Sorry guys, today I have my grandson at home. He's running around. I'm gonna stop him. Just a second. So that was the process. But again, there was another challenge. Challenge was this. There's always a true side. When you will go work as an architecture, you will see the environment is going to look like this. You will have one environment called like a development environment, and then you will have a operational side. So this is going to be operational team. So development going to do the development, and the operation team going to, after once you complete the development, is going to pass on to their outcome, their application to the operation team, and the operation team going to test it, going to run this, and going to use on the daily basis whatever the functionality is. For example, this is a bank, and the developer developed the bank application and hand it over to the operation team. Operation team is still having a lot of issue. They say, you know what, this is not working. This is not working in our environment. What are we supposed to do? And they are again the blame game. Even though we develop everything through the Agile methodology, we use the Agile, and we develop the application in small chunks. And then even though every time they pass on these things to the operation team has some issue with that. The reason is, so if I develop something, for example, I developed something in Windows 10. So in Windows 10, I developed something on my platform. When I hand it over to the operation team is running Windows 8. Or maybe running Windows 10 as well. But maybe this machine does not have the patches, up-to-date patches installed on it. Or maybe some patches are missing. So that's why the software team who developed this application is not running on their operating system. So they always coming back to the development team, and this fight was going on for a long time. So the solution for this, they came up with a new methodology called Devops Methodology. Dev stands for development, and the ops is for operation. So DevOps, in the DevOps, what you do, they actually combine the two teams to work together. So, and also the process was, the way they designed this methodology, the both team going to work together, and they're going to work on each and every line of the code. I'll show you in the next slide what exactly that means. If I write a code, like one line of code, developer team write one line of code, and it's going to go to the the different stages. It's going to be testing will be done, and then it's going to go to the production. So the development team going to pass on not only the code, but is going to pass the environment in which they created this application. If I created in a Windows 10, so I am going to give them a Windows 10 environment plus the application which I developed. So the production team and the development team will be testing and working together at the every stage of the application. How they're going to work, let me show you that. So when I said that they're going to give them the same environment, what comes into your mind? I'm running here window, and I'm giving them the same environment to test my application. So what comes into your mind? So giving somebody environment. Anyone? All you need is this little thought process. Look at the, think about the instances. How we create the instance. No guess? Remember we learned about the image and snapshots? Anyone who can explain to me what is image?
Sir, the image is जो already existing किस्म का Amazon के अंदर पड़े हुए instances उनको आप ले सकते हैं समझें as pre setup instances, so they are called AMI or images.
Exactly. So if I create something on image, like let's say my image ID is IM123. So I am using this image to develop the application. So when I write this code, all these codes, I'm going to pass on this image to the operational team plus my codes. So now operation team cannot blame anything, cannot say, okay, this system is not working. So everything going to be replicated and duplicated from the development to operation. So this is how they combine this, the development and the operation side. So architect is going to look like this. Where is Agile? So this is the flow of DevOps. So we call this a CI/CD, continue integration and continuous deployment environment. So what happened here? The person who is developing the application, developer, going to develop the application and is going to give to the next stage. These are the stages called version control. Then we have a build, then have a unit testing, then deploy to test, then auto test, deploy to production, and then measures. Measures mean monitoring. So you're going to monitor what is happening. So what happened at any stage, for example, the developer developed some application, he has written some code, and he going to pass on to the version control system. Version control going to send this information to the build stage, build phase. In the build phase, it's going to check your code, and if something goes wrong, it's going to send that back right from here, back to the developer. It say, okay, your code is not working. Then it's going to start all over again. See, he has just written 4 or 5 lines, and he's going to test it. It's giving to the build, and the build is going to start building it. And during the building, so it's say your code is not working. It's giving me error, and it's going to pass back to the developer. Developer going to make the changes, look into the error, going to make the changes, and again it's going to pass on to the build. So this time when he make the changes to this document, this is going to be version 2. The first code he provided to the build was version 1, and then second time when it failed, and then he make the changes, now this is going to be version 2. So that is called version control. Every time he make any changes, even though if he put like a little dot into the document, the document's version going to be changed. So they now, which one is the latest and greatest version of the code is there. So it's going to be forwarded to, which is to the build, and the build going to, once it's going to successfully build, when I say build, it's going to change your code into the executable file. So this is the software development process. You don't need to learn about this, how they going to execute, but all you need to remember these stages. So once they pass on to the build going to convert the code into executable file. Once the file is ready, it's going to send to the automatically going to send to the next level, which is going to unit testing. So whatever we created, that are going to be test is called unit test. So you're going to test only one unit of this software. So if something goes wrong during the test, same process. It is going back to the developer and then same cycle. So it's a continuous integration. And if this gets passed, go to the next level. If it fails here, and then again back to the developer. So right now, everything is happening on the development side. So once they do complete the auto test, when the system pass okay, all the codes are good, everything is okay, it's working, then it go to the operational team here. And in this operation, then they use other tool to deploy this application into the production environment. And then obviously they're going to use some sort of monitoring system to monitor. And then again, for example, you completed your login page. Now the next is going to create a page for your shopping cart. So the same thing happen. Again, this is going to go through this cycle and operation and the development team working together to develop this application. This is called continuous integration, continuous deployment. So this is very, very hot right now in the market. They are looking for people who has a DevOps, who understand the DevOps methodology, and they understand all these stages. And each stages, these all stages where these stages I just show you, you're going to, it's not the manual task. This task is done by the different tools. For each stage, they have a different tools which are going to automate this process. It's not like if the build fail here, so it's not the human going to send back to the developer. It's the system. And what are those systems? I'll show you there. Where is this? Oh, maybe in slide. Here. So at any stage, you have different tools. So these are the name of the tools which are going to automate the process. So there's a tool like for the version control, they use the tool called Git. And the GitHub, you might have heard about this. So these are the tools, and the Jira and other tool. So what's the purpose of these three tools right here? This is connected to the code. They are version control. They control the version of the code. Every time you make a changes, they're going to be notified, and then they're going to take the next action, what they have to do with that. If the test is passed, then it's going to move this code to the next level. Otherwise, it's going to roll back and send back to the developer. So when it's come to build, so once the code is when the code is written and is sent to the build, in the build there are two tools here. One is called Maven and other is SBT. So Maven and SBT, they are these tools which are automatically going to convert the code into the executable file. So these are the names. Actually, you don't need to remember as a solution architect. If you remember, that's good. But you should know the process and the stages of this DevOps. And then once the build is complete, it's go to the next level called test. In the test, then they have a different tool called Selenium and the JUnit. So a lot of people, I can show you which tools are open source. Like a Git is open source, Maven is open source, Jira is open source, Selenium is open source. When I say open source, it's free available. So a lot of company actually using for their DevOps process, they're using the Git, Jira, Maven, and Selenium. So these are I think the JUnit is a paid software. So when everything testing is completed, then they go to the next level called release. So now the test has been approved, and now you're going to release and going to give it to the next level for deployment. So this kind of release is done by the Jenkins. Jenkins is a free open source software which is used for the release and for the configuration purposes. And they send to the deployment area. So now in the deployment, you have to deploy. And for the deployment, there's a concept called Docker. So I'm going to stop here. I'm going to give you like a high level knowledge on the Docker, what Docker is. So remember we learned about this virtualization. We have infrastructure, then we had operating system, and then we have a hypervisor for the virtual machine. And then on top of that, you can have your operating system. So this is called host operating system. And then each application has their guest operating system. So this is called containers, containerized applications. What is this? You will be sharing the resources, hardware resources, as well as the operating system resources in this case. So what we were doing before, there's another one, this one. So here, if you look on the left hand side, we have a virtual machine. So this is the structure of the virtual machine and the layers. We have infrastructure layer, then we have host operating system, could be Windows, could be Linux, or any other, could be a Mac. On top of that, we had the hypervisor. And then on the hypervisor, we had a guest operating system. I can install any operating system, Linux, and operating any Windows or Mac here, right? Then we have binaries and libraries for the operating system. And on top of that, we run our application. This was the scenario in the instance we are running. So far, we have seen all the instance all the virtual machine has this structure. What happened in the container environment, which is like also a virtual machine, but it works in a different way. They have infrastructure layer, they have their operating system, like a host operating system. Instead of hypervisor, they have a container engines installed on top of that on the operating system. Here, what was happening? Let's see, this is the infrastructure. In the infrastructure, I have, for example, 100 GB memory. And then I have 8 processors. So I was allocating this processor and memory to my guest operating system. I say I need one CPU. I need 20 GB of memory. So hypervisor was assigning these kind of hardware to the guest operating system in the virtual machine. So it was taking all this from the infrastructure through the hypervisor, and the hypervisor was assigning the, so this is going to be dedicated, going to allocate to me is dedicated compute power. So dedicated compute power, that's if I say I need 20 GB memory, so does mean I will get the 20 GB. If I say I need 2 CPU, I will get a 2 CPU. So these 2 CPU is assigned to me on this for application 1. And how many left behind? We have 8, we have 6 CPU left. Now this machine said I need like a 4 CPU. So this is going to assign this 4 CPU to this machine. And then same thing, the rest of the memory is going to assign to this one. So in this case, we have allocated all the hardware to our virtual machines. Now these machines are running on this dedicated hardware. What if this machine is not using the 2 CPU? It's using maybe in 24 hours, maybe using for 4 hours. They're using the full capacity of the allocated hardware. And say, okay, they're using for 4 hours and he's using it like maybe 10 GB memory as average most of the time. So again, the hardware capacity is being wasted here because we have allocated to this system, and its system is not consuming 24/7. It's consuming maybe when they have a peak time and they start using the full capacity, but most of the time it's staying idle. It is not working. So in the container environment, this machine, these things are from here to here called container. So this is container 1. This is container 2, and this is container T. So each of these container, I am running different kind of applications. And if I need, for example, in this series, I have like 100 GB memory, and I have 10 CPUs. Here I don't get any, there will not be allocation of hardware in this situation. This container will not get any kind of memory, will not get any kind of CPU dedicated to this one. So we're going to create this image, and container engine will work with this container. Every time this application need any hardware and software, the container engine will come here and will say this container A, B, and C. He said container A need like a 2 CPU. So on ad hoc basis, it's going to give him a 2 CPU. And he says he needs like a 40 GB memory. It's going to give a 40 GB memory. And once the things is done, so these things are gone. It's going back to the infrastructure. So it's on the run basis. When it run the application and it's consumed the resources, at that time, he will get all these resources from the infrastructure through the container engine and do his work and task. And once the task is done, and now all the memory and all the CPU power will given back to the infrastructure layer. So this is how they can run small containers on top of this containerized environment. So in this case, they don't have their guest operating system. There's no guest operating system, because they are taking not only the infrastructure but the operating system from the container environment. So itself, they don't have any operating system. They have only binaries and libraries which are required to run their application. They don't have a full-fledged operating system. Like, if you install the Windows, it's going to take maybe 30 or 40 gigabyte of your your hard drive. So here we don't have any operating system. We have only the few files, binaries and library which is supporting to run this application. So this is called container environment. So container environment doesn't have its own operating system, doesn't have any kind of hardware dedicated to it. Every time it's a need per go. Like if they need something, then it go and get the hardware from the infrastructure layer. So these kind of things are very popular right now. A lot of companies, they are using the container environment, and this is what I was talking about. If I build something in this container, I build the application, I can pass on this information to the operation team. I say, here's my image of my container, and here's my software I developed. This is my developing software. So I'm going to pass on to the operation team. Operation team will take this image and going to create their own container with my image, which is going to be the copy of this, the exact copy of this, and the application I have developed on this, and that application will go as well with the container image, and now he can run the application, and he has no complaint about that, because I developed my application on this container, and the application I have passed on to the operation team. The operation team can successfully run the application. Any question? Anyone understand the container and the virtual difference between virtual machine instance and the container? So what is called, we call this is software level virtualization in the container. We say software kind of virtualization. Here we call the hardware virtualization. So this is another name for this one. Software virtualization or operating system virtualization, and here we call the hardware virtualization. No question?
No, sir.
Okay, clear? Everything is clear? So when we do this kind of environment, so this flow of developing and deploying is called the Cicd pipeline. So you will hear this a lot at the workplace. So we have built the Cicd pipeline. In the Cicd pipeline, I just gave you example. At any stage, if something fails, it goes back to the development team, and development team then rework on it and develop the new code and new version of the document, and pass on, and that's go through all these stages and finally go to the production. So this is the flow. So right now, if one of you are going to go and try to look into the any job website, you will see they were looking for a DevOps engineer, with the solution architect, with the understanding. It's not like you're going to work as a DevOps engineer or DevOps project manager. Because I am a project manager, so if I add this skill to myself, so it's going to be having this background how to run the project, and then having these new tools, so it gives me an edge. But as a solution architect, if you understand the environment, once there you design the system for the company and how the system going to implement and how many stages they have to go through to finally deploy the system, and what tools they will be using. So this kind of knowledge you should have is going to help you a lot. So right now there's look at these statistics. A lot of companies, they are adopting this methodology because it's fast, it's scalable, it gives you a result oriented, it gives you a result so quickly, and you can make the changes as you are developing the system, not after having a complete application and then you decide, we don't want this feature and this function and go back to the drawing board and start all over again. So see the 62% right now automating and orchestrating IT system and processes. Right now a lot of companies are growing every day actually. So development and operations are working combined together with the collaboration of to going through this infinity, what is called infinity circles. So this is what's happening right now in the industry, especially when it's come to the software development. So this is another picture of a Cicd pipeline, and at what state of what we do here. We have a Git where we actually store all the codes. It's called Git repository. So you store all your code in a repository, and from this repository you start working, you start building, you start unit testing, you start packaging. So you should now actually these terminology, unit testing, packaging, and run integration test. Integration test is when you have two components and they are going to integrate and you're going to test both of them all together. For example, selecting the items from the shopping cart and finally going to the payments, which was a checkout. And if you see that the process is working, these two processes are integrated so tightly and they are working. So this kind of testing called run integration test. And deploy to test, then you test. Actually this is a pre-production test. You see if we're going to deploy in the production, and that you do this like a drill, actually putting it on the real production environment. So these are the stages. If you look into this and you study, it's going to help you. They might going to ask you question on this. How much do you know DevOps environment, DevOps methodology, and what is the Cicd pipeline? So you should be able to explain that. Okay, this is not for you. So let's do the exercise. Let's create So this is what we did yesterday, and we're going to do this today in a different scenario. So this is company. They have their own private network. They're having their infrastructure on the premises. ये भी cloud में नहीं है. This is their own location. The company is like they're running the social network application, and this is their original setup. They have two web server, which is a physical server, and then they have behind that they have one application running on two servers. So two web server and two application server, and everything they are doing, they are having like any kind of transaction, any kind of information they are having at the back end. They have a SQL database. So they have a load balancer in front of that, these two web servers, which is going to distribute the traffic among these two web servers. And obviously because they're publicly available, so they have a DNS name, which is mysfb.com. So DNS is going to resolve their DNS name into the IP address, and from the IP address is going to the load balancer, and from the load balancer is going to the web server, and this is how from the web servers they're going to reach the application, and that's how the system is. This is the flow. So what happened? The company became famous, and it started growing, and they had more people coming to visit their website. They have more audience. They have more members, and then they allow the people to create their profile, which is they can upload their picture, they can upload their username and password and all those kind of information, and their geographical location and their age and all those things. And for that, the unstructured data, they have no SQL database running down there. And they also have a caching because the traffic is growing and they are getting a lot of requests from the database, and they implemented the caching. This is everything's happening on the customer side. Now they are having a media files. People are uploading the media files, and the media files is being loaded to the external storage, and they have their own storage system where they every time somebody upload the media file, and that media file get loaded into the external storage. Rather than storing on this database, they have external storage. And they also cautious about what kind of content is coming to their website, and they have some sort of filtration going on. They're going to content the filter to look for the inappropriate pictures or contents. And they also want to see what is happening, how many people going to click on their website, and they want to implement a clickstream analysis. So whatever I'm telling you right now, this is the business this is called business requirement. This is the business is telling you what they are doing. You are not going to invent it. It's the business is giving you environment giving you the requirement. So this is the requirement I am showing you. The business is going to tell you. So they also want the clickstream analysis, and they want all the data from the click should be stored in an external storage again. From here, they said we also want to. This is what's happening right now in their premises. They say we are doing like data analysis. So we have a big data processing is done, and then the next thing they said, we also getting the data from the unstructured and the relational databases, and we are getting the data into the big data warehouse. We are going to do the further analysis. So this is collecting the data, capturing the data, and getting into the data processing applications. And after once it's completed, they say we apply that they have their own tools which they are using to create the business intelligence, to look at how their system is performing, how many people are getting in, how many people are buying, how many people are just clicking and just leaving the website. So they want all kind of analysis done, and they want that in like a visual database, a visual report and visual graphs in the field. So for that they have their own business intelligence tool. And then we see a lot of people, actually the company is growing, and they are using a different browser. They're using the Explorer, they're using the Chrome, they're using Firefox, and they're trying to get these pictures from our website. And we also have a user actually who trying to come to our website, and they want to they're using a different kind of devices. It's a mobile phone, it's an iPad, Not everyone is using the desktop and the laptop. So for that we have a different storage, and we are actually going to convert this video formation so they can fit to their screen. And we are doing this, we're getting this the images from this storage, converting it to scale up to the level so they can be utilized by the other devices as well. So this is the requirement the customer going to give you. And then they say, because we have a presence in other country as well, so what they have, they have their own location in different countries, and they have in that location they have their physical server sitting there. So the local audience from that country or from that region, they can have access to those storage, and they can look into their content. So this is the entire environment they have in their private network, and this is their requirement. And they also, because they have a mechanism, if something goes wrong with their system, if one system goes down, they have a system administrator, and system administrator will be informed through the push notification, some kind of SMS messages he will receive, or maybe he can get like email, or he may be getting any kind of other source of messaging queue. This is not for here actually. The messaging queue should be like a communication between actually this is monitoring the messaging queue, which is actually being used for the communication between different resources. And obviously they have a mechanism or system available to them, which is actually looking at the overall health of the system, is if every component of their environment is working. So this is the requirement they give you, say this is what we're doing at our site. So you as a solution architect going to sit down with them, you're going to look at this diagram, they will show you this, they say this is what we're doing right now, and now we have a plan to go to the AWS Cloud. So what we're supposed to do? How are you going to provide all the system we already have, but it's definitely is costing them, because to keeping them up to date, keeping them up and running, they need a lot of resources, and they are 100% responsible for the security, for the infrastructure. And if somebody hacked their website, they're gonna have a lot of issues. Then maybe one of their system need to be upgraded. So all those hassle, they want to avoid this hassle. They say, no, we don't want to continue doing what exactly we're doing in our data center. We want to have where we can just lease the infrastructure, and we can just utilize these computer resources and pay as you go. So for here, it is getting harder and harder for them to maintain their data center and to keep up with the latest and greatest technology. So they decided to go to the AWS website cloud. So let's see what happened there. So now you're going to walk me through to tell me what solution we have in AWS to meet their requirement, whatever they are already doing in their own site. So let's start with now we are getting into AWS Cloud, and this is the VPC. The first thing we have to do for this customer, we have to create the VPC, right? I want to guys interact at this time because this is going to be fun. So what should we do with the DNS and load balancing? What we are offering in AWS?
So क्या मतलब?
Now we are giving this customer who was running his system in his on premises, उसका अपना data center था, वहाँ पे वो run कर रहा था. This was the environment they have given to us कि ये हम कर रहे हैं already. अब हम इसको क्लाउड में लेके आएंगे और क्लाउड में हमें इसको क्या क्या वो सर्विसेज हैं जो कि एक तो इनकी रिक्वायरमेंट को मीट करेंगी और इज़ गोइंग टू मेक इट बेटर देन व्हाट दे वर डूइंग बिफोर. So first thing we did, we created the VPC for this customer in the AWS so they can have a logically isolated environment. So this is what we did. So we created the logical isolated environment by creating the VPC. Now these things what they were doing, they had their domain name service, they already had a load balancer. What services we are going to use in the AWS cloud?
Do we use Route 53 for DNS?
Okay, done. And we're going to replace their physical server with the virtual server Amazon S3, right? EC2, right?
Yes, sir.
Okay. And load
balancer, elastic load balancer आएगा यहाँ पे.
And this EC2 instance will have elastic block storage attached to them. So in case if one of the servers goes down, they still have a data. So this is the most important thing. And now we have elastic load balancer as well. Okay, what's next? Let's see.
Sir, notifications के लिए SMS.
Yeah, we go there. So now now we want this system because we have the people are growing right here. So before they didn't have any like auto scaling. So now we are giving them a new feature, say because your customer is growing, you might consider to having auto scaling. So we are offering him like auto scaling as well. So maybe in a peak hours, we can have a more server automatically add to their existing infrastructure. So auto scaling, another thing we're going to introduce in this environment. And then we have a database down there, RDS, which is just like the same they had in their own premises. And for the profiling, we have a DynamoDB structure, unstructured data. And what else for caching? What are we going to offer for caching?
I think there's two, isn't there? There's Memcache and Redis. I can't remember.
Yes, exactly. So we're going to offer them Elastic Cache. And then in Elastic Cache, we have a two kind of caching. Yeah, you're absolutely right. So let's put here Elastic Cache. We can select any one of them. What's next?
I think maybe for clickstream analysis, maybe Kinesis, because that's live data.
Yeah, let's see. We go there. Let's go for the external storage. What are we going to have for external storage?
S3 maybe?
Yes. And for the content filtration, we have this Amazon recognition. And then for the what was here?
Video conversion.
Yeah. So we had Lambda function. The Lambda function, every time the content is loaded to this bucket, it's going to trigger the Lambda function, and Lambda function job is to convert those those images into the sizable format so can be used on these two kind of devices. And you are right, Nasheen, for the click stream, we're going to use the Kinesis data stream. What else? So for big data processing, we have Elastic MapReduce. It's going to replace with the EMR. And for the extraction, transformation, ETL, the system they are offering in Amazon called Glue. So we will use Glue because Glue was a part of the analytics course, but I just introducing you. This is the purpose of the Glue services is going to extract the data from different data source. Is going to extract from the so it's going to extract the data from any kind of data source. This could be like an RDS, could be a non-structured. So the tool they use is called Glue here, right here. And once we have this Glue going to extract the data and going to pass on to the EMR. EM going to process the data and going to give it to the Redshift for the data warehousing. And once we have a data warehousing in place, now we have all the data here for the analysis purpose. What kind of data we have in data warehouse? OLTP or OLAP?
I think TP.
OLAP or OLTP. That's the name of two kind of data transactions. So in the data warehouse, we have OLAP or OLTP.
So I think OLTP.
Okay.
I think it's OLAP.
It's OLAP. So anything you want to analyze, so that's going to be an analysis will be done on the historical data, and the data warehouse deal with the OLAP kind of data. So OLTP are done here in RDS and the DynamoDB level. Even in the big process, you can talk about the OLTP, but once you go to the data warehousing environment, those going to be OLAP. And then Amazon has the two tools called Athena. Athena is nothing but the query. I think I discussed yesterday. Is going to run the query on the data warehouse, and after the query, the data is passed on to the business intelligence tool called Amazon QuickSight. And the QuickSight is going to show you the visual format of the data. So far so good. So we started with creating the VPC for the client, and now we are replacing the services they were using in their environment with the services in the AWS. So what's next? So we have a content delivery network here. What we should do with that? It's a CloudFront. And what else is associated with CloudFront? CDN. What?
CloudWatch.
CloudWatch is for watching the environment, watching the system. But when we talk about the CloudFront content delivery network, Netflix. The example is Netflix. CloudFront. Anyone? I think you forget about the edge locations.
Oh, yes.
Right? So we are having a business is growing. People are coming all over the world, and we want to facilitate them without having latency. so we can actually use the CloudFront with the edge locations. So now we'll look at the operation and monitoring side on the left hand side. So now we have everything in place, and we're going to monitor the system, and we see how these things are working when we come to the operation. So definitely, if you have a failover, if something goes down and something happen with the system, you will be notified using what?
Sure, SNS, SQS, and
SNS.
function.
And then you can also have can be notified through the via email, and the service Amazon offering via email is SES, simple email services. And the component talking to each other in the application. In this application, they are using the SQS. And to monitor the whole system, each component inside this VPC and the VPC and all the subnets. So we will have what to monitor? What?
CloudWatch.
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 So that's it, guys. This was so what in this exercise we did, we moved everything from the customer side to the AWS side and replaced all the services they were running physically on their server and their systems with the fully managed services. For example, Lambda, EMR, and Redshift, these are fully managed. DynamoDB is fully managed. Elastic Cache is fully managed. And now they don't have to worry about how they're going to manage their resources, and they will be analyzing their system using the Cicd data stream, and then they're going to store in the S3, and from the S3 they can have a big data processing implementation. They can process, they can see the streaming data, and they create once they're going to analyze, they can actually move on to the big data warehouse. In the data warehouse, they can create intelligence on top of that. On the left hand side, they have all kind of information available to the health of their system. They are running, there's failover, the capacity challenges, they are reaching to the threshold, they need more computing power. So we actually provided them everything in the cloud, more than what they had before.